Just add water. In seconds, dry granules dissolve into a steaming cup of coffee. But behind that simplicity lies complex industrial science, a process that must preserve volatile aroma compounds, prevent flavor destruction, and create granules that dissolve instantly in boiling water. This isn't just dehydration. This is preserving complexity while removing 98% of the liquid. The global scale. More than 3,000 cups of instant coffee are consumed every single second worldwide. That's 10.8 million cups per hour, 259 million cups per day, 94.5 billion cups per year. To achieve that scale, flavor must survive dehydration, months of storage at room temperature, and global transport across continents. Coffee is volatile. Aroma compounds, the ones that make coffee smell incredible, evaporate easily. Heat can destroy delicate flavor notes developed during roasting. So how do you remove 98% of water without destroying what makes coffee? Engineering tension. Traditional spray drying blasts. Coffee extract with 400 to 500 degrees Fahrenheit air. Fast, efficient, but harsh. The problem? High heat destroys aromatic compounds. What's left tastes burnt, bitter, astringent. Everything you don't want in coffee. Freeze drying solves this by keeping temperatures at minus 40 degrees Fahrenheit to minus 50 degrees Fahrenheit. Volatile aromatics stay locked inside the coffee matrix. But there's a catch. Freeze drying takes 16 hours per batch. Spray drying? Seconds. The battle between quality and scale defines the instant coffee industry. Inside the system. Today, we step inside the freeze-drying plant, where coffee transforms from liquid to crystal without ever becoming liquid again. Extraction. Columns. Brewing at industrial scale. The process begins with roasted coffee beans, typically Robusta beans, 75% of instant coffee, or a blend of Robusta and Arabica. Why Robusta? Higher caffeine content, 2.7% versus 1.5% for Arabica. More robust flavor that survives processing, and lower cost for mass production. Beans are ground and fed into massive extraction columns, steel towers several stories tall. Hot water, pressurized and heated to 175 degrees Celsius, 347 degrees Fahrenheit, flows through the grounds under controlled pressure. This isn't brewing. This is industrial-scale extraction optimized for maximum soluble yield. Temperature and contact time are calibrated precisely. Too hot or too long, and bitter tannins over-extract. Too cool or too short, and flavor compounds remain locked in the grounds. The goal? Extract soluble flavor compounds, caffeine, acids, sugars, oils, while preventing bitterness from over-extraction. At Nestle's Derbyshire factory, these extraction machines produce 18,000 liters of liquid coffee concentrate per hour. That's enough to fill 72,000 standard coffee mugs every single hour. Aroma recovery, capturing what evaporates. As extraction occurs, volatile aroma compounds escape with steam. These are the lightest, most delicate molecules, the ones that give coffee its characteristic smell. If allowed to escape, they're lost forever. Specialized aroma recovery systems capture these vapors and condense them back into liquid form. Think of it as distilling perfume from flowers. The aromatics are separated, concentrated, and stored. These preserved aromas will later be reintroduced to restore the coffee's signature scent. Without this step, instant coffee would smell flat and lifeless when you open the jar. Vacuum concentration, evaporation without destruction. The liquid extract, now full of dissolved coffee compounds, enters vacuum evaporators. These are massive tanks spanning multiple floors. Nestle's Derbyshire evaporator is 6 stories tall and holds 1 million cups of coffee. Under reduced pressure, vacuum, water boils at much lower temperatures, around 70 degrees Celsius, 158 degrees Fahrenheit, instead of 100 degrees Celsius. Why does this matter? Physics. Lower boiling point means moisture removal without excessive heat damage. The extract thickens into a concentrated syrup without scorching or burning. This concentration step removes about 50% of the water, intensifying flavor like reducing stock on a stove. 30,000 liters, 6,600 gallons of coffee move through the evaporator pipes every hour. Rapid freezing, locking in structure. The thick, syrupy concentrate is pre-chilled through heat exchangers, then poured onto stainless steel conveyor belts. These belts carry the extract into giant freezers, operating at -40 degrees Celsius to -50 degrees Celsius, -40 degrees Fahrenheit to -58 degrees Fahrenheit. Rapid freezing is critical. Slower freezing creates larger ice crystals, which damage coffee structure and create a porous, weak product. It can also affect color. Faster freezing creates smaller ice crystals, preserving cellular structure and maintaining quality. The frozen coffee forms solid slabs, hard as rock, ready for the next stage. Sublimation. Solid to gas without liquid. The frozen slabs are broken into granules and placed inside vacuum chambers. Here's where the magic happens. Sublimation. The chambers maintain extremely low pressure, vacuum, while gently heating the frozen coffee to just above freezing point. Under these conditions, frozen water doesn't melt into liquid. It transitions directly from solid to vapor, skipping the liquid phase entirely. This is the same process that makes dry ice smoke at room temperature. Dry ice sublimes. Solid CO2 becomes gas without melting. Why is sublimation better than melting? Because liquid water would dissolve aromatic compounds and wash them away. Sublimation removes water while leaving flavor compounds trapped in the coffee matrix. The water vapor is sucked away by powerful vacuum pumps and collected by condensers, the most critical and expensive component in freeze-drying plants. The removal of water vapor is vitally important. Without efficient condensers, the process fails. The frozen water expands to 10 times its previous volume as it sublimates, creating a porous, sponge-like structure perfect for rapid dissolution, granulation, and sorting. The freeze-dried slabs emerge as brittle, porous sheets. They're mechanically broken into granules. Screening systems ensure consistent particle size, typically 300, 600 micrometers. Uniform granules dissolve predictably in hot water. Too large and dissolution is slow. Too small and they clump together. Any granules that are too big or too small are recycled and reprocessed. Packaging and protection. Sealing freshness. Instant coffee is hygroscopic. It absorbs moisture from the air rapidly. Exposure to humidity causes clumping and degrades flavor. Oxygen causes staleness. Packaging must be airtight. Before sealing, jars are nitrogen flushed. Oxygen is replaced with inert nitrogen gas to prevent oxidation. Glass jars with metal lids provide excellent protection. Foil-lined pouches work for single-serve packets. The coffee remains shelf-stable for months or even years at room temperature, a convenience impossible with fresh brewed coffee. The numbers. Industrial scale. 1 in 14 Americans drinks instant coffee regularly. Freeze drying. 8, 16 hours per batch. 10 to 30%. More expensive. Superior flavor. Spray drying. Seconds per batch. Cheaper, harsh flavor. Nestle Derbyshire Factory. 18,000 liters, hour extraction. 30,000 liters, hour evaporation. Caffeine content. Instant averages 66 milligrams per cup, range 29 to 117 milligrams. Slightly less than brewed. From pressurized extraction at 175 degrees Celsius to vacuum evaporation at 70 degrees Celsius, from rapid freezing at -40 degrees Celsius to sublimation in near vacuum, industrial physics preserves global flavor. Liquid transformed into crystal. Water removed without melting. Aromatics captured and returned. Complexity reduced to simplicity. Just add water. Subscribe for more deep dives into the engineering behind the products you use every day. Thanks for watching.